Okay, so this is an eighth grade book here that we use in South Florida. But anyway, let's go over what this problem says, because it says for exercise 6 through 12, write a rigid motion that produces each image. And so they take all the different, triangles, except for DEF, they have it just one time where you're going to transform it, and then the rest are GHJ. So ABC and ABC to DEF, so you're transforming, ABC to GHJ, ABC to KLM, number 9 is ABC to NPQ, and number 10 is ABC to RST. Now let's look at the definition before we get this confused. A rigid motion is a motion that causes a transformation where the shape and the size stay the same. So this triangle, although it has different x and y coordinates, it's still the same size. It is still the same size. Okay, so so we've got to get our points here, and here's one of the things that's going on. This O looks like a 0, so when you're up here, make sure you know that your zeros are here. And even though I put 1 and 2 over here and -1, I didn't want to get rid of the angles, but this is really where the -1 should go and the -2 should go, and that will help you. So when you look at the points, you look at what DEF is. So you have your ABC over here, and you have your DEF over here, and you have to look at the points. When you look at the points, you take the first one for A, and the next one for D, and you go 2 plus some number equals -4. And I'm going to write what 2 is. It's A, and I'm going to put small x, because that means x's value. And 4 is D, and I'm going to put a little x. It's its value. So you're looking for the change along the x line. Okay, and the change along the x line is whatever this value is. Now, keep in mind, because -4 is here and this is positive, this is +2, -4, your answer has to be negative. So it's plus -6, which means that from here moved over 6 points. So let's see if that happened. 1, 2, 3, 4, 5, 6, and it did. It moved over to the left. Let's call it move. Six. And since it's to the left and you're on the negative side, it's called a -6. So it moved over to the left 6, which is here, but then what happened? 1, 2, 3, 4, and up 4. So it's to the left. This is what's called your movement over the x. I don't even want to say over, because sometimes over can be around the y. So this is x's movement. And x is what? Right here. The x line is horizontal. So if you were on a test and they said, what is a horizontal movement? You would have to know. I'm just going to put x. Well, it's really, in math they call it a movement, but we could have left move. And so this is what's happening. So it moves over -6. That's the first translation. But it goes up. Why? Another thing, let's go over rigid transformation, that the shape and size stay the same. So these are still the same shapes and sizes no matter how much they move. So like, you see how I have this here? Even if it moved to the right and it went, this is still the same shape and size. If this went over here and you took this, I'm a bad drawer, excuse me, and you took this over here and you went like this, and you move this shape would still come over, it could still come over here. And let's just pretend. But it's just moving to the other side, the left. So let's get that. Okay, now you need to write a rigid motion, because they're asking you what the transformation was. Well, you did move 6 units over. How'd you move 6 units over? Count these lines. 1, 2, 3, 4, 5, 6. Okay, to go from your original coordinate of this here A was 2 and negative 2, you moved over 6. And you went up 4. How do you know you went up? 0. You went up 4. Okay, 6 units. Over. Now over to the left. So that's going to be what? Negative 6. But you went up 4, which is what? Positive. So you were at negative 6 and 4. That's your transformation. But we're not done there. We have to take these numbers and add them. Hey guys, see, I remember I said move 6, and see how I have here that this is negative 6? So it's negative 6 over to the left, over here, and up 4. So this right here in blue is your y value, and this is your x value. And you do that for each one of these. So your original point for B was 4 plus negative 6 I'm going to write that better. 4 is positive. B's value is right here. 4 and negative 3. But the x value is 4. 4 plus negative 6 is going to give you negative 2. Why is it negative? Because this number is bigger. So you see that? That's your x value. So it moved up. Now let's see if E is negative 2. Well, negative 1, negative 2. Okay, and why is it 1? Because I'm going to do this in navy blue. B's original value is negative 3, but 4 units up equals 1. And that's what we have, negative 2 and 1. So you do the same thing for C, and you are going to get what for C? 2 plus negative 6. This is how you check yourself. So you don't have to worry about, once you get how many times it went up, you kind of have this. It's going to be negative 4. Don't we have negative 4 over here? Yes, we do. Don't we have negative 4 over here? Yes, we do. What's our y value? C is negative 3. Sorry, I have to stay active. Plus 4. It's going to give me 1. Is that what I have? Y value. Y value. Let's make sure. For F is negative 4. So it's negative 1, negative 2, negative 3, negative 4. And since your 0 was here, it really kind of only moved from what? From its original, which was up from C 1, 2, 3, 4, and over 6 gives you that value. Okay? Negative 4. And it went over how many? It's up on the 1 here. It's negative. Okay, so rather than sit here and try to do um, the mathematical equation, because if you try to do a mathematical equation, once you get out and you start doing the other numbers, like the other letters, the other variables, B and C and H and J, and you start doing the numbers that they belong to. Like if you try to do this here, okay, you're gonna get messed over. Well, this works for A, and this works for a transformation up, and it works for A. Sometimes they may not work for the others, but the transformation or the transfigured image, however you want to say it, is going to be the same. I told you. Okay. So your transformation is still going to be 6 over and 4 up. Here's the thing. Make sure that if you have to, you remember some key that this is over. You would think that people would, but sometimes people don't look at this and they do the math. And they start doing the math. This is 6 over. I'm going to draw like this crooked arrow here. It's 6 over and 4 up. And I took a different colored highlighter here. So you had 1, 2, 3, 4. That's actually 3, 4, 5, 6. And you go up 1, 2, 3, 4. Okay? And this is here to the first one. So let's go to G. 1, 2, 3, 4. It's more like a 5. But that's why we're just doing straight transformations, because once you moved A over to G's position, the other ones aren't going to move. Now let's see if they move over from B to H. So B was here, 1, 2, 3, 4, 5, 6. Kind of not, because H is here. But let's see if they move up 4. 1, 2, 3, 4, 5. See, they don't quite go over. So you use A's position, and you just remember the transformation. And then once you put A on a list, let's say these triangles weren't drawn for you, you just write their numbers. And here's how they come out. -2 and 2, -4, 3, -2 and 3, and all you have to do is go up and look at where the position is. Okay, so you have your triangle GHJ. Now let's try number 8, KLM, and let's see if for A would equal K. So A is here, 1, 2, oops, that is really 3, 4. See how K is here? But it goes up 1, 2, 3, 4. So since they're not asking you to find out what's happening, you just go on ahead and you plot the points that you see. And I put the 0 here, and don't think about this too much. This is what everything comes down to. Your next question talks about a glide reflection. It's a combination of two rigid motions, which includes a reflection over a line and a translation along the reflection. Okay, so listen. Your reflection point would be here or here, where the triangle turns around. So if you wrap this around again, this is going to be a reflection because the image is going to be the same. I'm going to attempt to do this. Well, it's done for you. That's a reflection because your S is here, this. If you fold them back up, they're all going to come back to, you pretend like you're folding an envelope, and they're all going to come back to this image, which I'm not drawing so well. But they're going to come back to the same triangle. So this image here is, if you roll it over, one rotation here and another one is going to be a reflection. So it's two rigid motions. Most of the time, if you have two rigid motions, you have a glide reflection. So you had an image change from here to here, D, E, F, and then you had an image move A, B, C to G, H, J. So you already have your two rigids from those. Okay, so these first two, this one to this one, this one to this one is another one. But then they had you change A, B, C to triangle N, P, Q, and that was across the vertical line here. So you have a rigid motion, and so you have a glide reflection.